they weren't. You get close. Hey, you've tuned in to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. I'm Tom Cyberlick, and I help lead the Wireless Center of Excellence at Cisco. If you don't know, the Wireless Center of Excellence is a team of wireless architects across the U.S. and Canada, and you can engage us anytime by contacting your local Cisco account team, and they will get us engaged promptly. Today, I'm happy to host our second Cisco Unplugged, and this is a recurring live broadcast with technical experts from Cisco to help you keep you in tune in the world of Wi-Fi networks and connectivity. We have a lot of great content lined up, and we will dive deeper into Wi-Fi 6E and beyond this season. So tune into our upcoming episodes to learn more. You see the Cisco Unplugged schedule up here. So please go out to our cs.co Unplugged and register for all the upcoming sessions. And we also will be having a YouTube channel, and please subscribe to that YouTube channel as you will get all of the latest content that we deliver, plus any of the new, you'll know instantaneously when we are streaming live, like right now. So please go out and register for that. Today's session is Wi-Fi 6E, device classes, and AFC. And today we will have Mark Tomaszewski out of our Cleveland office, Richfield, Ohio, joining us to talk about this. Mark, happy to have you here.
Well, thank you very much for having me, Tom. I'm really excited about talking about 6E and the new device classes and some of the new technologies that are coming out because of the 6 gigahertz band itself.
Well, we're looking forward to it, Mark. Thank you. But before we get started, if you haven't joined the Slido, please join the Slido. We will be taking questions and answers there. We will also be doing surveys and other communication for this event through the Slido app. So please join that and ask whatever questions you feel necessary, and we will answer them promptly. So without further ado, I will hand it off to Mr. Tomaszewski. Take it away, Mark.
Thank you, Tom. Appreciate it. So today in the session that we're going to talk about expand upon what we first started talking about in episode 1. In episode 1, we really talked about the 802.11 Wi-Fi 6E type technology itself, what it has to do, why it's beneficial. And we're going to expand upon that. So if you haven't had the opportunity to take a look at episode 1, feel free to do so today because it's very exciting, really talks about the technology itself. We're going to expand upon that, and we're going to really talk about what the device classes are. So we mentioned it earlier in episode 1. We really talked about the benefits of Wi-Fi 6E and the opening up of the 6 gigahertz channels, but we need to expand upon that a little bit better. So what are the benefits? And this is just a quick recap of episode 1. Wider channels, the ability to get more bandwidth because of those wider channels. The RF itself is a lot cleaner. There's not a lot of individuals that are operating within 6 gigahertz. We really don't have to worry about legacy technologies that we had to when we were working with 5 gigahertz. Remember, in the 5 gigahertz band, it started out with 802.11a, moved up to 802.11n, AC wave 1, wave 2, AX. They all had to interoperate with each other. We're really starting out with a greenfield type environment in the 802.11 world because the 6 gigahertz didn't have any of those legacies technologies that are out there. So we don't have to worry about those. We also, when we moved to 6 gigahertz, made it a much more secure environment as well. Again, because we didn't have to adhere to those older technologies, we were really able to start with that greenfield environment and get a lot more secure. Management frame protection and all the other enhancements, WPA3, etc. The discovery method was actually enhanced so that we could get onto the access points in a much quicker fashion. So that helped out in those time-sensitive type applications like voice and video when you're roaming from one 6 gigahertz cell to another 6 gigahertz cell. And of course, what we're going to expand upon today, the additional spectrum. The ability to open up 1.2 gig worth of spectrum to be able to handle all these devices, to be able to reduce the co-channel interference, and to have a much better experience overall. So let's talk about the band itself. I mentioned the 1.2 gigahertz capacity that we have. It's actually broken down into several different types of separate frequency bands. You'll notice Uni 5, 6, 7, and 8 are opened up. A Uni, for those of you that are new to the technology or I want to expand upon it, is unlicensed national information infrastructure. If you remember in the 5 gigahertz band, we had Uni 1, 2, and 3, and there are different rule sets on a per Uni band as well, as far as how much you can transmit as far as power levels, what the channels were available within those individual bands themselves. So you notice in this particular presentation or slide that there are a multitude of different channels. For example, there's 59 20 megahertz wide channels. We really don't need that many channels per se, because when you have that many channels, the throughput's not going to be as great. So we're going to start seeing most individuals, when they operate within the 6 gigahertz band, actually go to 40 and 80 megahertz wide channels, which we didn't have that luxury for in the 5 gigahertz band. And then if you're really adventurous, you can even bring it up to 160 megahertz wide channels. You'll notice that there are 7 non-overlapping channels. Now, I mentioned this in the context of the whole 1.2 gig band, but remember, we're not operating only in the US, we're operating in Canada. There's operations in South America, Europe, Asia Pac. These are all different regulatory domains that specify which portions of the bands that you can use. So you notice on the bottom in yellow, the FCC operates within a specific area of bands. The blue clients, the blue is for clients. And we'll talk about the differentiators between them in the next subsequent slides. But you look at the decibel level, the dB, the power output. We're allowed up to 30 dBm EIRP. That's out the antenna. For a quick recap, transmit power plus antenna gain equals the EIRP, effective isotropic radiated power, and that's 30 dBm, which is equivalent to 1 watt. If you look at ETSI, for example, it only operates within a specific area of the 6 gigahertz band. So be aware of the fact that I'm going to be talking about this in a broad fashion, but specific countries are going to have different regulations based upon where you're deploying these particular access points. So let's talk a little bit more about the equipment classes themselves. From an equipment class perspective, we had to actually divide them up a little bit because there are different legacy operators that do exist within the 6 gigahertz band, and we really had to take and coordinate with them when we wanted to deploy an unlicensed, free to use 6 gigahertz access points, being the 6E access points. So we had to really take into consideration not disrupting their existing services. So the first category class or equipment class that was introduced was called LPI, low power indoor. And it was limited to that 1 watt that I mentioned earlier. It's an indoor only capable device. So you'll notice that every 6E capable access point that's in the marketplace today is going to be a low power indoor access point. That means that there are some restrictions on that. Can it use the full 1.2 gig area of the spectrum? Yes. It does require, though, an integrated antenna. And the reason being is that if you had the capability of putting an external antenna, you would have the potential of exceeding that 1 watt power output EIRP that I mentioned earlier. So we really had to, the FCC and other regulatory domains really had to condense that down a little bit and make it so that it was usable and not disruptive to existing operators that were out there. But as we know, RF, and especially in deployment considerations, there are different applications. For example, point-to-point links that you may want to incorporate. Maybe you have, a warehouse or a distribution center where you want to be able to control your RF and use directional antennas instead of omnidirectional antennas. So they had to open it up a little bit, and they did that through the use of what's called a standard power access point. The standard power access points, again, are going to have some rule sets based upon them, and we're going to get into that in some of the future slides that I have today. They can use either an integrated or an external connection. That external connection, again, the EIRP has to be below 4 watts. And again, depending upon what regulatory domain you're within, will determine that EIRP value. But it also requires what's called automatic frequency coordination, AFC. We're going to get into that a little bit more in depth later in the presentation because there's a lot of concepts that you have to take in consideration when you're working with AFC itself. The next equipment class is what's called very low power. Very low power is another equipment class that I would consider more like a PAN device, a personal area network device. Very low power, very limited range, won't interfere with any of the other devices that are out there or existing operators that are out there. Does not require AFC, but it's not meant for, really meant for a ubiquitous RF coverage throughout a specific building, carpeted space, or what have you. So we are going to start seeing very low power access points in the future, but the major access points that you're going to see today will be the low power indoor access points that are out there. And then lastly, the client devices, they have their own equipment class. And that equipment class is specific to clients themselves. The clients themselves are indoor through the control of LPI access points, or they can be outdoor as well, but they have to be, if you notice on the bottom bullet point, a maximum power of 6 dBm lower than the access point's maximum power. So if they're connected up to a low LPI access point, depending upon what frequency that you're operating within, and we're going to talk about that in a little bit, or what your channel width is, we're going to talk about that as far as having 6 dBm lower than the AP's maximum power. One of my peers is going to talk in episode 3, and they're going to talk about how are we going to design this RF, but today's conversation specifically for the equipment classes themselves. So you get an understanding of where these different organizations, how they determine what we can and can't use, and what are the rule sets pertaining to that.
Hey, Mark, we've got a question that came through.
Yes.
Will the low power indoor NIC in my laptop be able to use standard power in the future?
Yes. It will be able to connect up, and we'll talk about that when we get into the standard power access points themselves. It's really the access point itself that's doing the controlling of how much power output it can have. And then the client itself will go 6 dB lower than that maximum transmit power.
Very good. Thank you.
So from a power level perspective, the LPI, and we're going to talk about this in the next slide, is 5 dBm per megahertz of the channel width itself. And we're going to talk about what that means, because when you have wider channels, your power output actually gets greater because there's a concept that we're going to talk about in the next slide that allows for that power distribution across the wider channels itself. Standard indoor power is limited to, or excuse me, is maxed out to 36 dBm or 4 watts, but it is with the automatic frequency coordination that I mentioned earlier. But you will notice that specifically for the FCC, that you can only use the Uni 5 and the Uni 7 bands. The Uni 8 is excluded from that. Again, different regulatory domains or regulatory organizations are going to have different rule sets. So again, if you're in another country that does have a specific rule set, you will have to adhere to those rule sets. From a manufacturing perspective, when we homogenize these specific access points to go, we adhere to those specific rule sets. Just like we have country codes for your 5 gigahertz and 2.4 gigahertz radios, we have to adhere to those country codes when you're talking about the 6 gigahertz band as well. Very low power, again, it's under evaluation. I am not aware of any very low power devices that are out there as of today. Not that there aren't any, but that's not the marketplace and the area that I'm going to focus on today. And then the clients, again, they can operate across all the different channels, all the different spectrum that's out there. And it's 6 dB less than the access points maximum ERP, like I mentioned earlier. So let's deep dive a little bit more into the LPI side of the house. It uses a concept called power spectral density. In our next episode, episode 3, we're going to talk about that because that's really, has to do with how you're going to also do your site surveys and your access point placements throughout your environment as well. It's 6 gigahertz is measured by that. And when you look at it, we have 5 dBm equivalent to about 3.16 milliwatts. And if you do the calculation, you'll notice that the wider the channel is, the more power output that you will see out of this. And again, we can't exceed the 30 dBm, but we are getting very close to the 30 dBm when you're talking about a 160 megahertz wide channel. Remember that 3.16 multiplied by 160 is actually equivalent to approximately the 27 dBm. And again, that's EIRP. So transmit power plus the antenna gain will give us that EIRP value. And again, indoor access points the clients themselves are going to have to follow that PSD rule of 6 dB less than the access points EIRP. If you look on the right-hand side, there's a table for this as well that you can use as reference. But this is a good indication of what LPI is really meant for. And again, the whole concept of LPI is meant for the ability to not interfere with existing carriers or existing links that are out there today. When we talk about standard access points, standard power really changes a little bit because when you're talking about standard power access points, the access points allow for that external antenna connection. It only operates within the Uni 5 and the Uni 7 band within the US or FCC guidelines. And again, as I've mentioned earlier, please follow your country for that information. It does require what's called automated frequency coordination. It's really a central database of the different frequencies that are used by these individual carriers or the devices that are out there that have actually paid for that spectrum. So they actually go out to the FCC, get a license, have a point-to-point link, and actually have to adhere to certain regulations as far as how much they can transmit as far as power levels and different antenna gains and such like that. So we have to be aware of those on a per geographic location. So those particular devices or existing carriers or operators might be in Houston, Texas, but that same operator using that same frequency might not be in Cleveland, Ohio. So I can reuse that frequency because I'm in Cleveland, Ohio, but not necessarily in Houston where that might be used.
So Mark, I'm assuming that we need that because the APs are in that same band now, and we can't step on a provider or somebody that another organization that's using that frequency band.
Absolutely. Because again, they've paid for that specific use of frequency. So because they're an incumbent, we don't want to interfere with those. That's why initially we came out with the LPIs, and it was easy to get us to marketplace with the LPIs But when you talk about standard power, there's a lot of coordination that has to be done. And we're going to talk about this in a little bit as far as who is doing that coordination for us and what references do we have to make on a per geographic location.
Good, thank you.
But standard power devices can be deployed indoors and outdoors. And we're going to talk about some of those deployment models a little bit in the next couple of slides. And remember, I talked about that client power. It still has that PSD rule of 6 dB less than the access point. So it is still adheres to the LPI standards coexisting and the same or similar to the standard power standards. Probing is not allowed. We're really trying to reduce the neighbor messages so that we're not interfering as much out there. And when we're talking about hotspots are not allowed. And the reason being is we might be able to locate the access point, but what about the different clients that are associating to that access point or different other devices, maybe a workgroup bridge or something of that respect that are attaching to it. So hotspots are really not allowed because they're, I don't want to say the word transient, but they're not going to be fixed on a regular basis. Whereas we want to be able to have that category of fixed, knowledge out there so we're not interfering with any incumbents. Which leads me into vehicular deployments. Those vehicular deployments, because they're mobile, are not allowed as well. Because you don't know where that specific end device is, and you don't want to interfere with or potentially go into that zone of interference to an existing incumbent either. We have to report. There's a lot of reporting that's done. All these devices, or in the case of a proxy, being a controller of something of that respect, must report their serial numbers and FCC ID number or regulatory domain number, depending upon where you are within the world itself. Fixed client devices can be used at the same power level, but you have to adhere to the same restrictions. So in that sense, you're creating a point-to-point bridge. And we're going to talk about some of those concepts again when we get into the next couple slides themselves. So, AFC. Why is it necessary? What, Tom?
What is going on, Mark? There's interference on the line. I cannot hear you at all.
You can't hear me now? Can you hear me speaking now?
Not clearly, I can't.
Well, that sounds like an 802.11 interferer out there. So our voices are communicating to each other. We're using a specific frequency that I can hear, you can hear, and we're able to converse. And in fact, we're using a concept called collision avoidance. You're letting me speak, and you're not speaking because you hear something on the airwaves, and you're holding off before you have a chance to speak. That's collision avoidance. We've had that concept for a long time with 802.11 world. But when you're a fixed transmitter, an existing incumbent, there's a potential that your interference is going to cause disruption for that fixed service. So there had to be something that was done, and what was done was called automatic frequency coordination. So those fixed services, us speaking together, didn't want to have any interferers going onto that same band. So if you look, you can go onto specific regulatory domain servers, or websites, more than likely. FCC has one. I've listed it on the bottom, that there's a licensing system, and you can actually find out based upon your geographic location if there is a fixed incumbent service. But that wasn't something that we wanted every individual device or customer to go out there and find out, hey, what's operating now in Cleveland, Ohio? I'm located in Richfield, Ohio, and I want to know all the different devices that are out there, what frequencies they're using. There had to be something that was out there to be able to coordinate those efforts. So let's talk about those components themselves. First of all, there's potential to have a mobile operator out there in your specific geographic area with an existing links which are licensed. So again, a licensed link, they're paying for a service or paying to use that specific spectrum. They don't want to have a third-party device coming out online and being able to disrupt them. So we have access points now out there. Those are standard power access points. So again, LPI didn't have to worry about that because they're indoor access points, the skin of the buildings, you having attenuation in it. They're not really protruding outside of the skin of the building under normal circumstances. But with standard power, because it has a higher power output capability, external antennas, potentially point-to-point bridging, they have to be able to locate those specific device. And when I say locate, we're talking about GPS style coordination. And then there has to be some centralized database somewhere that is communicating to both the fixed mobile operators as well as giving the access points the knowledge of that so that they don't interfere or tromp on existing mobile operators that have paid again for that spectrum. So the concept of an AFC operator was utilized. And with that, the AFC operator has some things that it has to adhere to as well. It has to have a database lookup for all those existing devices that are out there. So a fixed mobile operator, if you remember on the previous slide, actually has its GPS coordinates on there, where it's located, what its two fixed sites are, if it's a two fixed site location, what frequency it's using, as well as what power output it's using, so that it's coordinating with the regulatory domain. But the AFC operator has to gain that access as well. They have to be able to have a validation of those different IDs that are out there. And based upon that, it will compute for you so that you don't have to do it manually, the allowed frequencies and power levels that those standard access points can utilize so that there's a cohesive, non-interfering symbioncy or a symbiotic relationship between the mobile operator that's already fixed as well as the standard power access points.
Hey,
That
Mark.
does mean though that we have to have some GPS coordination that's involved. So we are going to have to introduce a new concept when we talk about standard power access points for geolocation.
So, Mark, a couple of questions came in relation to this. Who are the AFC operators, and will they charge for this service?
That is a great question. There has been certified 13 different AFC operators. And if you go onto the FCC website, you can do a quick search, FCC AFC operators. Or if you're looking for in general in your specific geolocation, you can look at AFC operators themselves. And there is a charge for that service. That charge for that service is still being worked out within the industry itself as far as how they're going to be compensated for that. So stay tuned for that. I don't have the exact answer for that because it's still a work in progress. But it is a charge service for that AFC operator to be able to handle all these different standard power access points. They're going to start communicating to it for these specific applications.
Very good. And another question came in. I assume the AFC operator needs to know my location. How will my network tell the operator where I am? Is this GPS on the APs? I can answer that question, but you go ahead.
The GPS needs to be, and we're going to talk about this in a little bit of slides. The GPS has to be located either near the access point or very darn close to the access point. And we're going to talk about different concepts that are being introduced when we're talking about how it's coordinated through that. In fact, let's talk about some of this implementation itself. And in the next slide, I'll get a little bit more into the different zones that we're going to take in consideration with this. So the location of the device has to be determined with a 95% confidence level. meaning that when I place my GPS and that GPS coordinates are sent to the AFC operator, I have to be 95% confident that that access point is within that area of that GPS coordinate. And when I say 95% confident, let's say, for example, I have a GPS coordinate of XY coordinates, and I send them up to the AFC operator, and I say, I am 95% confident that that specific access point, standard power access point, is within 100 meters of that GPS coordinate. I am now good to place an access point anywhere within the circumference of 100 meters of that specific GPS location. But we're going to talk about this in a little bit. What happens if I say I'm 95% confident that the access point's located in Cleveland, Ohio? That means that I have to abide by all the different fixed incumbent devices that are located in Cleveland, Ohio. But if I narrow it down to it is located on, Main Street, address 123, and I have a 95% confidence level that instead of the city of Cleveland, that is within 100 meters, that's going to reduce the amount of specific incumbents that I have to really be concerned about. So we're going to talk about that a little bit more in depth in the next slide or two. Based upon that, that power level will now be determined. That power level has to be so that it's 6 dB lower than the noise floor of the incumbent itself. So there's a lot of different coordination that's being done that's calculated out based upon the AFC information that's sent back to the controller or access point to determine what different frequencies or channels it can utilize and what power levels it can utilize within those channels. It also has to take in consideration the height of the antenna. For example, if I'm on top of a hill, it's different than if I'm at the valley, especially when you're talking about terrain that's not exactly level. So the height has to be given as well above the ground, because you don't want to have an antenna that is 50 feet up and potentially going to cause an interference, where if it was at ground level, it might not have caused that specific interference. So accuracy level needs to be reported back to the AFC system itself. A single outdoor access point, like I mentioned, has to either have an internal location device to report the location, or it can use a GPS that's attached nearby to it. For indoor deployments, those accuracy boundaries, we'll talk about this in a little bit, have to be within an 95% confidence, like I mentioned earlier, and then any other AP near that or within that confidence level will be allowed to operate in that specific area as well. So that means if you were to take a look at it, you don't necessarily have to have every access point have a GPS on it or a GPS location. You have to have a GPS location, and then all the access points within that 95% confidence can operate within that specific area. So let's talk about that for an example. If let's talk about the upper right-hand corner. I have a 95% confidence level that that specific access point is in that specific green circle. I now send that information up to my AFC operator, and the AFC operator comes out and says, you know what, there's nothing around you. You can operate at all the different channels. But you notice that there's a fixed incumbent, an incumbent that has a fixed service already in place. If I were to move that access point or have the access point in the red area, I have that same circle, the same confidence level, but the overlap between the red circle and the incumbent is out there. So if the incumbent's operating at Uni 5, for example, and the Uni 5 bandwidth's eating up maybe about 80 megahertz wide of the spectrum, the AFC operator is going to come back and say, you cannot use that specific channel allocation because you are going to interfere with that incumbent fixed service. So that means that that particular red area of circle on the bottom left has to adhere to that AFC operator's information because it gathered that information from that database that we talked about earlier in the conversation. And now it can operate, but not operate on those specific channels. So it might move to a Uni 7 band, for example, still be able to be utilized. Now, this is a one point-to-point link example. There could potentially be multiple point-to-point links. So based upon those geographic location, GPS coordinates, height of the antenna, all the other information I get that we're giving up or we're getting will determine what frequencies that I can use within that specific area. So remember, the accuracy zone is distance, whereas your confidence is based upon the percentage. So your confidence level means that I'm 95% confident that I know that access points within that red zone. Because of that, I have to adhere to the incumbent's fixed service information. In the green zone, I'm 95% confident that the AP is located within the green zone. I don't have to worry about it because I'm not going to interfere with that specific incumbent fixed service. That's with an outdoor. It gets a little different when you're talking about an indoor scenario itself. So let's pretend that that same incumbent is located out there, and I have a building that's located near that incumbent. If I put my GPS coordinates in the center of the building, I'm 95% confident that any access point within that area is capable of being placed in the specific area itself within that building. I send that information up to the AFC operator. The AFC operator looks at it and says, you know what? Based upon your GPS coordinates and your confidence level, I know I'm giving you permission to use that same frequency band that incumbent, but if you cannot go outside of that confidence area or that confidence level. Let's say, for example, though, I move the GPS coordinates to the edge of the building. In that edge of the building, I now have a confidence level of 95%, but you notice that it goes outside the building a little bit. And it does overlap the incumbent's fixed service connection. It's going to now tell you that any access point within that 95% confidence level that you gave me from a GPS coordinate standpoint cannot use that specific frequency that the incumbent is using. So you'll have to adjust your frequencies to avoid the interference from that incumbent that's already sitting out there. So that's why and especially in the next episode, we're going to talk about deployment models and how do you do access point deployments within a standard power system. You will get this information and be able to work with this. So it's a little bit of a different concept of just having coverage. You also have to work in coordination with existing systems that are out there. Now, granted, from an indoor perspective, you're going to probably use LPI devices, so this would not come into play necessarily. But if you're in a warehousing or distribution center where you do need some antenna, directional antennas or something in that respect to sprinkle in, you are going to start having to adhere if you're using standard power access points in conjunction with LPIs. So that's something you'll have to be aware of when you're doing an indoor style deployment. So from an industry perspective, there are different organizations that help form 6 gigahertz and helped allow us to get in the 6 gigahertz band. Obviously, this FCC and the country regulatory agencies that are out there, they set the standards for each individual country. And those standards take in consideration the power output, what frequencies can be used, et cetera, within the 6 gigahertz bands. The FCC, though, has conditionally approved 13 of the organizations to operate at those AFCs. So those automatic frequency control operators that are out there. There's a URL if you'd like to take a look at them to get a listing of the different operators or the AFC operators that are out there. The IEEE, though, they're the ones that actually formed the 802.11 standard itself. So the 802.11 standard, how we transmit data from the client to the access point, pretty much the layer 2 stuff, that's done through IEEE itself. They define those protocols, but they have to adhere to the FCC guidelines that are out there or the different regulatory agencies that are out there, depending upon what country you are in. Now, another organization is the Wi-Fi Alliance. The Wi-Fi Alliance actually tests the interoperability of the different Wi-Fi devices out there. They've been around for quite a long time. They tested out the interoperability for your 802.11a, N, AC Wave 1, Wave 2, took all the different clients that are out there, made sure they are interoperable with all the different access points that are out there. They also have a 6E standard that they're going to be testing interoperability with. And if you go to the Wi-Fi org page, there is a listing of how they did do that testing if you're interested to see how they're testing the interoperability between client devices and the 802.11.6E access points that are out there. And then Cisco, we have an 802.11.6E LPI access point right now. And that 6E access point, the 9136 or the 916X platform, will operate in the 6 gigahertz spectrum. Those are LPI products. We're in work right now to develop and introduce a standard power access point. The date on that's TBD, but it's something that we are very enthusiastic about and want to introduce I'm hoping this year that we will have something of that respect to be able to offer the industry. So this is a growing industry. 6 gigahertz is growing. It is very exciting to see this much spectrum, this capability that's being introduced to our clients and customers out there. So, Tom, are there any other questions that might have arisen when we've had this conversation?
There are 3 questions still, Mark, and thank you for that great in-depth discussion on 6E device classes and AFC. That was great. So first question, is AFC supported in 17.9?
No, not at this moment, because AFC, we don't have a standard power access point as of right now, so it is not in 17.9 code.
Okay. Will AFC be included in existing DNA licenses?
That I am not 100% sure on. I think that would be something that we would want to communicate with our business units on. So I do not have the specific answer for that as of right now. And again, because this is on YouTube, this is March 1st. We may, there's going to be subsequent information that we're going to getting from the business units on that. So let's stay tuned on that one.
Got it. We will circle back and post that somehow on the YouTube channel to answer that question. Last question. In my network, I have 1572s with GPS outdoors. Can these be used to provide my location to the AFC operator?
Wow, that's a great question. That I do not know for sure. When we introduced the standard power access points, from a Cisco perspective, that would be something that we would have to talk to the business units on to see if that would be, applicable and adhere to the different standards that are out there, or the AFC operating information that's necessary. But that was a great question. When we get closer to introducing the standard power access points, that's something that we should bring up to our business unit to see if that is something that is applicable.
Okay. We will make sure we circle back on that question also. Great. Thanks for all your questions. We appreciate it. Thank you again, Mark, for that. That was a great discussion. One thing we'd like to ask you all to do is please complete the survey that you get. We really appreciate your feedback. It's important to us. It helps us improve the quality of these broadcasts and helps us decide what our next sessions are. The next session, as Mark mentioned, will be 6 gigahertz RF coverage and comparing that to 5 gigahertz. And that will be on March 15th. So please, register, attend that. Again, we will be broadcasting these on YouTube if you subscribe to that, you will get an instantaneous message saying we are broadcasting live, and you will see all the cached content that we have on our YouTube channel. And lastly, just reach out to your local account team if you want to engage the Cisco Wireless COE. Again, we are here to help, and we are ready to help. So engage us, and we will be there with you. And until next time, stay connected and unplugged. Thanks again for joining.